So something important to note, let's say we have this coordinate system where this is the positive x direction, this is the positive y direction, and this is the positive z direction. Something important to note is if we apply a force in this y direction, if we apply a force in this positive y direction, will this box accelerate in the x direction? Well, no. If we apply a force in the y direction, we would have an acceleration in the y direction, but there would be no acceleration in the x direction. So that's really important to note. And for another example, if we apply a force in the x direction, then we would have an acceleration in the x direction. So therefore, it's important to note it's the forces in a particular direction that give an acceleration in that direction. And that's a limitation of this equation. When using this equation, you need to focus on a particular direction. For example, if you want to find the acceleration in the x direction, you need to find the forces in the x direction. So when using this equation, if you want to find the acceleration in this positive x direction, you need to find the forces in this x direction. So it's those forces in the x direction that you plug in here. Any force in the y direction doesn't impact the acceleration in the x direction. So any force in the y direction wouldn't be included in this equation. So that's a limitation of this equation. You can only limit yourself to a particular direction. You can only find the acceleration in the x direction. So however, if you wanted to find the acceleration in the y direction, you would need to reuse this equation. If you wanted to find the acceleration in the y direction, you would need to reuse the equation, but this time find the forces in the y direction. And then if you know the forces in the y direction, then you can find the acceleration in the y direction. So that's a limitation of this equation. When using this equation, you need to limit yourself to a particular direction. So let's do an example. Let's say we had that box. Let's say we have this box, and let's say it's feeling a force in this particular direction. So again, let's say this is the x direction and this is the y direction. And let's say it's feeling a force in this particular direction of 10 newtons. And let's say that this is the horizontal, so let's say to the horizontal this is 60 degrees. So in this situation, what would be the acceleration in the x direction? If we apply a force in this particular direction, what would be the acceleration in this x direction? How do we find the acceleration in the x direction? Well, again, we just use this equation. The forces in the x direction equals the mass times the acceleration in the x direction. So if we want to find the acceleration in the x direction, we need to find the forces in the x direction, and we need to know the object's mass. So let's say the object has a mass of 5 kilograms. So if this object has a mass of 5 kilograms and it feels a force in this particular direction that's 60 degrees from the x direction, what's the acceleration in the x direction? Well, again, we need to find the forces in the x direction. And something important to note is that this force in this 10 Newton has a component of this force has a component in this y direction, and it also has a component in this x direction. If we have a force of 10 newtons in this direction, we know it's made up of these component vectors, a component vector force in this direction and a force in this direction. And it's these two forces that make up this 10 Newton force. So if we have this 10 Newton force, all we're interested in is the component of this force in the x direction, because we're interested in the acceleration in the x direction. So we only care about the force in the x direction. So therefore, we would need to find the component of this force in this x direction. And we know how to do that with a little bit of simple trigonometry. So again, this 10 would represent the hypotenuse of 10. We have a 60-degree angle. So with a little bit of trigonometry, we could find this leg, which represents the force in this x direction. And with a little simple trigonometry, we could see that this leg would be 5. So we know this component force would be 5 newtons. And again, you should be pretty familiar with how to do this trigonometry. The cosine theta equals adjacent over hypotenuse. So we knew all these terms and we could solve for adjacent, which was 5. But again, you should be pretty familiar with that. But again, if we want to find the acceleration in the x direction, we need to find the forces in the x direction, because it's only this 10 Newton force has a component force in this y direction, but that doesn't influence the force in the acceleration in the x direction. So we don't care about that force. We're only interested in the force in this x component, because it's only this force that contributes to the acceleration in the x direction. So this is the only force that should be included in this formula. So again, we know the forces in the x direction is 5 newtons. So we know it's 5 newtons. And again, it's positive 5 newtons, because we define this as positive x direction. So again, we know the mass is 5 kilograms. So now we can solve the acceleration in the x direction. So we would see the acceleration in the x direction would be 1 meters per second squared. So if we have this force of 10 newtons in this direction, we know it would have an acceleration of 1 meters per second squared in this x direction. And again, we know it would also accelerate in the y direction, because again, this 10 Newton force also has a component of that force in this y direction. So therefore, if we wanted to find the acceleration in the y direction, if we want to find the acceleration in this y direction, we need to find the forces in the y direction, because it's those forces that lead to an acceleration in the y direction. So therefore, we would need, if this 10 Newton force, we would need to find the component of that force in this y direction. And again, we could do that with trigonometry. And once we found that component of the force in the y direction, we can solve for the acceleration in the y direction. So that's a limitation of this equation. It's limited to a particular direction. You need to choose what direction, what acceleration, and what direction are we interested in, and then you need to find the forces in that direction. But something else important to note is, for example, let's say we have this object. And again, let's say it has a force in this direction of 10 newtons. And again, let's say this is positive x, and then this is negative x, and this is positive y, negative y. So let's say we have this 10 Newton force, and again, let's say it was 60 degrees to the parallel. And let's say it also has a force of 1 Newton in this direction. If we have this situation, what's the acceleration in the x direction? We want to find the acceleration in this x direction. So therefore, if we have these forces, how do we find the acceleration in the x direction? Well, something important to note is this f of x, if we want to find the acceleration in the x direction, we need to find the forces in the x direction. But this force is the net forces in the x direction. We don't just use this force because it has a component in the x direction, or we don't just use this force. We need to find the net forces. It's those net forces that lead to an acceleration. So we need to this side of the equation, this force side is really the net forces. We need to find the net forces that this object feels. So what are the net forces? Well, we know we have a 1 Newton force in this direction, and again, we know that's the negative x direction, so that would be a negative 1 Newton force. Then again, we know we have a force in this positive x direction. And how much, if we have a 10 Newton force in this direction at 60 degrees, we know we solved that this would have to have a positive 5 Newton force. So those are the net forces. We have a positive 5 Newton force that this object feels in this direction, and we have a negative 1 Newton force that this object feels in this direction. So now if we wanted to find the net forces in this x direction, because again, remember this is the net forces in the x direction, if we wanted to find the net forces in the x direction, we would have positive 4 newtons. If we have 1 Newton force in this direction, in this negative direction, and if we have 5 newtons in this positive direction, we have a net of 4 newtons. And it's this positive 4 newtons that leads to an acceleration in this x direction. So remember, this force is the net forces. So again, the mass, let's say the mass was 4 kilograms in this example, just for simplicity. So let's say the mass was 4 kilograms. And again, now we can solve the acceleration in the x direction. And again, we would, just simple algebra, we would get an acceleration in the x direction of 1 meters per second squared. So now we know if we have this 4 kilogram object and it feels a force of 1 Newton in this direction and 10 newtons in this direction, if we wanted to find the acceleration particularly in the x direction, we need to find the net forces in the x direction. And now we know this object would have an acceleration in this x direction, this positive, because of positive 1 meters per second squared. So therefore, we would move in this positive x direction. So we would have an acceleration of 1 meters per second squared in this direction, in this particular direction. So again, just a couple key points is this equation is limited to a particular direction. So when using this equation, you need to choose which direction are you interested in. If you're interested in the x direction, you need to find the forces in the x direction. If you're interested in the acceleration in the y direction, we would need to find the forces in the y direction, the net forces in the y direction, and that would give us the acceleration in the y direction. So again, and also remember, this force on this side of the equation is the net forces. This is the net forces in the x direction. We need to find the sum of all the forces in the x direction. And forces are additive, so you would add all those forces in the x direction. And if it's negative, then that would be a negative, and this positive. So you would add those. And then again, remember, these would cancel those out. But again, so you would find the net force. And it's then this force is the net forces in the x direction, because it's those net forces, it's that net force that leads to the acceleration. So this side is the net force, is the sum of all the forces, and this is the mass, and this is the actual physical acceleration that the object feels. This value tells us the actual physical acceleration that the object would actually feel.